Let's solve this example. Okay, so this we can't directly use here the substitution formula, so we have to first simplify this. Okay, so x square plus 1 upon x plus 1 the whole square. Now if I want this denominator in the numerator so that I can cancel it, okay, then you have to write something in the numerator such that it is in the form of a denominator. Now denominator is x plus 1 the whole square, so you can write this as x square plus 2x plus 1. Okay, now these two terms are there in the numerator. We want only this term, so I can add and subtract 2x in the numerator. So x square plus 2x plus 1 minus 2x. Okay, so I am adding and subtracting 2x upon x plus 1 the whole square dx. Okay, now I will write this as x plus 1 the whole square. Okay, so I am taking this denominator separately. Can cancel this, so this will be 1 minus, now again this is 2x, right? So if I take x plus 1 the whole square t, then the dt will be 2 times x plus 1, right? So I have to write this x in the form of x plus 1. How I can write? I can write this as 2x plus 2 minus 2. Okay, so here I can write square dx. Now this 2x plus 2 I can write it as, after taking 2 common, this way. Okay, we'll separate this denominator again. So this will go. Okay, or you can directly use here the t formula, that is derivative. Okay, now the integration of 1 is x, right? Minus 2, 1 upon x plus 1, integration of 1 upon x plus 1 is log x plus 1, and the derivative of x plus 1 will come in the denominator, which is 1. Okay, minus 2. Now here the integration of x plus 1 the whole square, you have to use here the standard result, that is x raised to n plus 1 upon n plus 1. So this will be what I will write here, x plus 1, if I take it in the numerator, this will be minus 2. So minus 2 plus 1 upon minus 2 plus 1. So this will be x plus 1 raised to minus 1 upon minus 1. So raised to minus 1 means this will come in the denominator. So this will be 2, 1 upon x plus 1 into minus 1. So I can take this as positive. Okay, plus c. Okay, let's solve this. So this is x raised to 4 minus x the whole raised to x by 1 by 4, and x raised to 5 is in the denominator. Now I will multiply and divide by x. Okay, x raised to 4 minus x raised to 1 by 4. I am dividing and multiplying by x. Okay, Now carefully look at this. If I take this x inside, okay, then how I will have to write this? X raised to 4 minus x raised to 1 by 4. So x I can write it as x raised to 4 raised to 1 by 4, right? Because 4 and 4 will get cancelled and I will get only x raised to 1, which is this, right? So I can take this inside, whole raised to 1 by 4 into x and this. So 1 upon x raised to 4 dx. Now do the division. So this will be x raised to 4 upon x raised to 4, which is 1, minus x upon x raised to 4, which is 1 upon x cube, whole raised to 1 by 4, into 1 upon x raised to 4 dx. Now you can take the substitution thing, that is, if I substitute this whole thing as t, 1 minus 1 upon x cube as t. 1 derivative of 1 is 0. Derivative of x raised to minus 3, I am taking it in the numerator. So this will be minus 3, x raised to minus 3 minus 1. So this will be minus 4 dt. And here you have to write dx. Okay. So this will be plus 3 upon x raised to 4 dx equal to dt. So dx will be what? 1 upon x raised to 4. This will be dt by 3. So substitute. So this will be t raised to 1 by 4 into dt by 3. Okay. So this 1 by 3 you can take outside. So integral of t raised to 4 is t raised to 1 by 4 plus 1, which is 5 by 4. We'll write here directly. Okay, divide by 5 by 4 plus c. Okay. Which is equal to 1 by 3 into 5 by 4. I take it here, 4 by 5. T, what we have taken t? 1 minus 1 upon x cube raised to 5 by 4 plus c. So this will be 15. So 4 upon 15, 1 minus 1 upon x cube raised to 5 by 4 plus c. This is the answer. Okay. Next is x upon root of 2x square plus 3 dx. Okay. So here you can use substitution method. So use t as t, you can substitute as 2x square plus 3. So derivative is 4x plus 0 dx. Okay. So your dx will be what? dt upon 4x dx. Now we substitute it here. So this will be integral dt upon 4 root t. Okay. So 1 by 4 you can take outside. So dt upon root t. Root can write it as t raised to half. Okay. So t raised to half, if I take it in the numerator, it will be t raised to minus half. So t raised to minus half plus 1 upon minus half plus 1. So this will be t raised to half upon half. Take this 1 by 2 in the numerator, so this will be 2 by 4. What is your t? T is 2x square plus 3, so we can write here 2x square plus 3 plus c. This is half. Okay, let's solve this. So dx upon the root of x plus 3 minus x plus 2 dx. So this you can solve by using rationalization. Okay, so rationalize the denominator. So you have to multiply and divide by this whole thing but with a positive sign. Okay, so this will be x plus 3 plus x plus 2, x plus 3 minus x plus 2 into x plus 3 plus x plus 2 dx. Okay, so this you have to use a minus b, a plus b formula, which is a square minus b square. So integral root x plus 3 plus x plus 2, root of x plus 3 the whole square is x plus 3 minus x plus 2 dx. So this will be minus, this is also minus, and this gets cancelled, so 3 minus 2 is 1. So this whole thing is your 1. Okay, now you can take the integral because there is nothing in the denominator, so you can solve this. So x plus 3 root, you can write it as half, and this also as half. Okay, so integral of x plus 3 raised to half is half x plus 3. Wait, this is derivative I wrote. So this is x plus 3 raised to half plus 1 upon half plus 1 plus, and derivative you have to multiply in the denominator. Now derivative of this function is only 1, so I have not written it. Okay, x plus 2 raised to half plus 1 upon half plus 1 plus c. Now half plus 1 is 3 by 2, so this will be 3 by 2. This is also going to be 3 by 2, and this is 3 by 2. So 3 by 2 you can write it here as 2 by 3. Okay, so this is the answer. Now how to solve this type of problems? Okay, so there is a rule here that says integral sine raised to m x into cos raised to n x dx. Okay, so if your m is some positive odd, okay, then you have to substitute cos x as t. Okay, if your n is some positive odd, then you have to substitute sine as t. Okay, now the third case is if both m and n are positive, okay, then you have to consider the smallest one. Okay, so let's start. Here the odd number is 3, right? Positive odd 3. So if I write this as sine raised to m and cos raised to n, then our n is positive, so we have to put sine x as t. Okay, then dt will be cos x dx. Okay, So before substituting, you have to reduce this, that is, it is in the cube form, right? So we need to reduce it to some square form or the cos form, because we have to substitute, right? So cos cube, you can write it as cos square x into cos of x into sine raised to 4x dx, sine raised to 4x dx. Okay, cos square x, you can write it as 1 minus sine square x. See, we are converting all the cos into sine because we have to put this t over here, and we need only one cos, that is, we don't need any cos square or cos cube, need only cos, because we have to substitute cos x dx as t. So this sine raised to 4 you can take inside, so this will be sine raised to 4 minus sine raised to, this is 2 plus 4, a raised to m into a raised to n is a raised to m plus n, right? Now substitute t, so this will be integral t raised to 4 minus t raised to 6 cos x dx is your dt. Now directly integrate. So t raised to 4 is t raised to 5 upon 5 minus t raised to 7 upon 7 plus c. Then you have to substitute what is t, so sine raised to 5x upon 5 minus sine raised to 7x upon 7 plus c. Okay, let's solve this. Here you can do substitution. Okay, if I write t as a cos square x, that is our denominator, then dt will be what? 2a 2 times cos of x, derivative it is now. Okay, then you have to take the derivative of cos of x, which is sine of x minus sine x. Okay, plus b into 2 times sine of x into derivative of sine, that is cos of x. Okay, now if we look at here, then this will be 2 times sine x into cos x, and here also it is 2 times sine x into cos x, which is our trigonometric identity sine 2x, but here it will be minus sine, and it is sine 2x. So you can take sine 2x common, right? So inside it will be b minus a sine 2x. Okay, so dt, we got dt here, so b minus a, sorry I have not written dx, you have to write everywhere dx. Okay, so our dx, sine 2x dx is dt upon b minus a. This will be 1 upon b minus a integral 1 upon t dt, which is log t. So t, whatever we have taken here, we have to write here. Okay, let's solve this. So 1 plus 10x is given, so you can use the trigonometric ratio. 10x you can write it as sin x upon cos. Okay, do the cross multiplication. So this will be cos x plus sin x upon cos x dx, right? So cos you can take in the numerator, cos x upon cos x plus sin x dx. Now we can't use here any t formula, so I will just multiply numerator and denominator by into 2. Okay, so cos 2x, so it is 2 times cos x, correct? So I will write here integral 2 times cos x means cos x plus cos x. So I will write in between sin x. So cos x plus one more cos x is there. Okay, we'll write here sin x, add and subtract. And there is half here. So I will separate the denominator dx. Okay, this will get cancelled, and this you can write it as, if I take t as cos x plus sin x, then what it will be, dt. Dt is derivative of sin is cos and derivative of cos is minus sin. So this will be my dt, right? So here it will be integral dt upon t, which is log t, correct? So half you can write outside. Integral of this 1 will be x, and this will be log of t. T is our cos x plus sin x plus c. Okay, let's solve this. So here it is given sin x plus a upon sin x minus a. Okay, so if I want to delete this, whichever term which is there in the denominator, I have to create it in the numerator, right? How I can create it? So if I need sin x minus a, then this term should be written in terms of x minus a, right? So x plus a, how I can write it as x minus a? How? So if I write 2a minus a, this will be a, right? So x plus a, I can write it as 2a minus a. So I have to add here plus 2, right? So I will write this sin x minus a plus 2a upon x minus dx. Okay, now you have to use sin a plus b formula, which is that your 11th standard trigonometry, sin a plus b. Sin a cos b plus cos a sin b. Okay, so I'm treating this as a and this as b. So this will be sin x minus a cos 2a plus cos x minus a sin 2a upon, now we'll separate this denominator minus a dx. Okay, I can cut this, right? And here I can write it as cos upon sin. The angles are same, so this is cot. So integral cos 2a. Now this is independent of x, this is not a function of x, so this becomes your it is independent of x, so you can take this outside, it becomes a constant. Okay, integral 1 dx plus, again sin 2a is a constant, so you can take it outside, integral cot x minus a dx. Okay, so cos 2a into, this is x, integral sine 2a, integral of cot x minus a is log sine x minus a, and derivative of x minus a is 1 plus c. Okay.